There's a ceiling to how fast AI can improve. And that ceiling is us humans as we write the rules to tell an AI how to get better. And they stay fixed until the humans decide to update them. Now, Meta just published a paper trying to remove that ceiling entirely. To understand why this matters, you need to understand how self improving AI systems work today. Right now, most systems work in two layers. There's a task agent that solves the problem, and a meta agent sitting above it that watches it fail and rewrites the logic. Think of it like a student and a teacher. The student does the work, the teacher observes what is not working and changes the study plan accordingly. This way, the student keeps improving. But the teacher's playbook was written by a human and it stays fixed. So, no matter how good the student gets, the ceiling for improvement is always set by whoever last updated the teacher's rules. This had already been partially solved for coding tasks because coding and self improvement happen to be the same kind of task. Gains in one naturally carry over to the other. But the moment you moved outside coding, the whole thing broke down. Here's where Meta introduces hyperagents. And the core idea is that instead of keeping the student and the teacher as two separate systems, you merge them into one program. The same system that solves the task also rewrites the rules for how it improves. And because those rules are now part of the same editable code, the system can rewrite them too. There's no fixed playbook anymore, no human in the loop updating the teacher. Meta calls this metacognitive self modification. And here is where it gets interesting. They trained a hyperagent on two things: reviewing academic research papers and designing movement instructions for a walking robot. Then they gave it Olympiad level math problems it had never seen before. A specialist math AI built specifically for that task scored 67%, whereas the hyperagent, which had never touched math, scored 70%. The reason it outperformed is because there was no fixed ceiling. While learning to review research papers, the system had figured out on its own how to build evaluation checklists, write its own memory, and track its own performance. It had learned how to learn, and when it hit a completely new domain, those skills transferred directly without any human updating the rulebook.